Hello, in this video I will show you how to use GAMS, the optimization package, for solving a nonlinear problem. You know GAMS stands for General Algebraic Modeling System. Is an optimization package like Cplex, Lindo and GRUBY that can solve also nonlinear problems. So imagine that we are going to solve this small problem. The objective function z is the 3 times x plus 5 times y subject to one constraint, x times x plus 2 times x plus y times y minus 5 times y should equal to 12. So this is, we have two decision variables x and y, and we have one constraint. We want to find the optimal value of x and y such that this z is maximized subject to this constraint. So to do so in GAMS, we open the GAMS application here. This is the GAMS environment. To define a new model, we go to File, New, and this is the window that we input our new model. We start by defining the decision variables. So looking at this problem here, we have two main decision variables, x and y, but however you will need to define a third decision variable for the objective function z as we have introduced here. So we say variables x, y and z, and then we put a semicolon to tell GAMS that this is the end of the line. And then we need to define the equations. In this problem we have two equations. The first equation for the objective function and the second equation is for this constraint. So we just need two equations. We say GAMS, we have these equations. So we give two names for those equations, arbitrary names. Here I use C0 and C1, and again semicolon at the end of the line. And then we start defining the equations. The first equation, which is the objective function, we put the name of the equation, that's is C0, and then we put two dots, and then we put exactly this formula here in GAMS. But don't forget that the equality constraint in GAMS is like this. So this constraint says that z, the value of z, should be equal to this 3 times x plus 5 times y. And again we will have the semicolon at the end of this line. And for the second constraint C1, we have the name of the constraint or equation, and then two dots, and again we have this. Exactly, we copy and paste here. So x times x plus 2 times x plus y times y minus 5 times y should be equal to 12. Again, the equality in GAMS is like this. Equal means equal. The next step is to define the model. We start by using the model and giving an arbitrary name to the model. So here, for example, I use my model, and then inside these slashes we give the name of the equations that should be included in this model. We can say this C0 and C1 and then slash semicolon. But if you are going to include all the equations in the model, you can simply just say all. And then I want to solve this model, so we say solve. Solve what? Solve this my model. And how I should solve this model? We want to maximize the z, so we say max z. And finally we should say we should tell the GAMS which solution method or which solver it should use for solving this problem. So since this is a nonlinear problem, we should say NLP, nonlinear problem, and again semicolon. And finally the last step is to display the value of the objective function or decision variables. So we want to see the value of x and y and z, but don't forget that in GAMS the last value or the level value of the decision variables, you should add .l for each of these variables to see the level value. Otherwise GAMS will return an error message. So x.l, y.l and z.l. so here defining the variables, defining the equations, and defining the model, asking GAMS to solve the model, and finally asking GAMS to display the value of the decision variables. We did, it's done. The next step will be to run the model, which will be by pressing on this button or pressing F9. When I press this run model, GAMS solves the model and it generates this report. So you see this report has different sections. It explains the equations, the column, and the solution, and variables, and the execution. For example, here we will see the solution, the compilation time, and when it was executed, etc. And if you open this display section and double click on one of these display items, you will see the values. After solving, GAMS has returned the value of x, y and z, as here x equals minus 1.615, y equals 6.844, and the z value was 242.038. So in this video I showed you how to solve a simple problem like this in GAMS. Thank you for your attention, and please like the video if you enjoyed.